Turn left.
Good afternoon,
50 feet.
and welcome to the Music and Technology Seminar at Carnegie Mellon. Our guest today is John Hardy, who, a generation or two ago, designed a world-class microphone preamplifier. That preamp and its nearly identical siblings is virtually unchanged from that initial design and is still considered one of the best pieces of audio gear ever made. Please welcome John Hardy to the Music and Technology Seminar.
Thank you all. Glad to be here.
So, John, I wonder if you could start by telling us the 2 or 3 primary ingredients of your preamp that makes it so good.
It's fundamental stuff. It's the world's best input transformer, in my very strong opinion, which is the Jensen JT-16-B input transformer, and there are reasons why it's the best. Following that input transformer, there's the 990 discrete op amp. Wouldn't you know, I don't have one sitting here, but might be able to see a clear 990. Where are we here? I can't. Yeah, there's a clear 990 from the early days. This is an MPC 500C, my first mic preamp card. So Jensen JT-16B input transformer, the 990 discrete op amp, which is also the circuitry was designed by Deane Jensen. And then on my full-size mic preamps where there's room for it, there's an output transformer as well. And that's the very best of the Jensen output transformers, the JT-11-BM. So you've got 3 critical parts there: the world's best input transformer, a superb op amp, the 990 discrete op amp, and then the world's best output transformer. And the last ingredient is there are no coupling capacitors anywhere in the signal path. Most audio equipment is full of capacitors to block DC voltages, because DC voltages always manage to creep into the audio, the AC signal path. And so the simplest way to deal with that is to send the audio through a capacitor. So the audio makes it through, but the DC voltages don't. The problem with that is even the best capacitors have a problem known as dielectric absorption. The dielectric is simply the insulator between the 2 plates of a capacitor, whether it's air in between there, or mylar, or polypropylene, or polycarbonate, or polystyrene, or poly this, or poly that, or Teflon, or whatever. Those dielectrics can absorb a part of the signal that's passing through it. Now, this is all relative, and it's not the end of the world, but I particularly remember somebody, and this is a totally unrelated sort of situation, but it gives you a general idea. I remember a friend of mine had ordered some electrolytic capacitors. They were large capacitors, maybe the size of, I can't say an orange juice can because they don't have those anymore, but imagine 4 inches tall, 5 inches tall, maybe 1.5 inches diameter with a couple of terminals at the top. And when they arrived, those 2 terminals were deliberately shorted together. So I remember removing the shorting link and coming back, I don't remember if it was an hour later or the next day, and shorting the 2 terminals together, and there was a spark there. How can that be when it was short-circuited for however many days it took for it to be shipped, and probably for weeks before that? So that just gives you some idea that capacitors are not the pure things that people would like them to be. So the best capacitor is no capacitor. So there are other things going on in all of my mic preamps that allow the complete elimination of capacitors. So best input transformer, best op amp, best output transformer, no coupling capacitors. You have an absolutely superb, best ever audio signal path, and that's why it sounds as good as it does. Now there's always details in terms of circuit board layout. If you don't lay things out right, it's not going to work as well as it could, but those are the key ingredients to my mic preamps. Any other questions? Or I'm willing to go in any direction here, by the way. If anybody has a question, you just jump in and let me know.
So how did you find all of these components?
Well, it probably started, I was aware of op amps, just monolithic op amps, the little chip op amps where an entire op amp circuit is built on a single chip of silicon with all the resistors and transistors and diodes, whatever, fabricated right on the chip. And as wonderful as op amps, monolithic op amps are, they have their limits. So at some point, trying to think of a timeline here, I think I became aware of Deane Jensen maybe around 1971, 1972. He had probably just started his transformer company at that point. And Deane was a technician at a major studio. I don't remember where. It's somewhere on the internet. All this information is available. But in his investigations, he realized that the transformers that people were using back then, had shortcomings. They they tended to cause harshness or distortion of one form or another. And so he deeply got into the designs of transformers. And Deane was just an absolute genius. He and some associates of his wrote a software program that ran on Hewlett-Packard computers of the day, which was 1971, 1972, a program called ComTran, and this was a circuit analysis program. So Deane was able to plug in all the different values that represent a transformer. You have coils of wire, so that's an inductor. That's also, there's resistance there. There's capacitance between the windings, and on and on. And if you can model that properly, then you can play with values and try to figure out what's going on. So Deane came up with superior transformer designs and hired a separate manufacturing company, Reichenbach Engineering, to manufacture the transformers for him. So I became aware of Deane in the early 70s and I actually visited him on a road trip I took to the West Coast. I think he was living at 1617 North Fuller at the time in Hollywood or Los Angeles, whatever. I remember going up to his apartment or condominium, and on his dining room table there was this big HP computer that he was using. And that program, by the way, this is a salute to Deane, this was the first program that Hewlett-Packard ever sold as a third-party software program. If you bought software from Hewlett-Packard up until that point, it was something written by people at Hewlett-Packard, but Deane has the honor of presenting or providing the first program to be a third-party program. So Deane just applied all this knowledge to improving transformers. And then somewhere around here I have a module from a console project that I took on in 1977, a huge project. I designed and built 2 audio consoles for a sound company based in Chicago, DB Sound. They had been doing sound for the group Kansas in years past, and for the fall of 1977, I think Kansas told them, you need to get some better equipment. So I knew the people at DB Sound. I'd done some smaller projects for them, and they hired me to design and build these 2 major consoles. So of course, I used close to 100 channels of the particular Jensen input transformer that was probably the best one, generally speaking, for the type of op amps that I was using in these consoles. And that was the JE115KE input transformer. And important, I'll jump into this a little bit. Jensen makes a variety of models of mic input transformers, and mainly they vary in their impedance ratio or turns ratio or step-up ratio. So the transformer that I use with the 990 is the ideal impedance ratio to match perfectly with the noise characteristics of the 990 op amp. It has a 1:2 turns ratio or step-up ratio. So if you apply 1 volt of signal to the input, you'll get 2 volts at the output. It's just this 1:2 step-up ratio. The transformer I used in the consoles had a 1:10 ratio. So if you put in 1 volt at the input, you get 10 volts at the output. So you might think, well, gee, the more gain I can get from the transformer, the better, because that's free gain, relatively speaking. There's always physics involved. Nothing is free. But in the world of a mic preamp, you can step your voltage way up and there's little trade-off to that in some respects. But laws of physics at work, the higher the ratio, the more nonlinear the transformer will perform. It's just physics at work there. And obviously, the lower the ratio, the more linear it will perform. So out of all the Jensen mic input models, originally the JE-16, in fact, originally, I'm getting into the tall grass here, originally there was the JE-16-A, which had a round shield can. But then, 1980 or so, I decided to design my MPC 500 mic preamp card, and the round can was too large in diameter to allow the width of this module to fit in a 1.5-inch wide modular format for the MCI 500C series consoles. There are a lot of consoles out there that have 1.5-inch wide modules. So when the round can is 1 3/8 inches wide, and you've got a circuit board and another circuit board, and it's just not going to fit. So I contacted Deane, and I suggested that he do a square can version. I can just hold up this guy here. This is a rectangular can version, but you get the idea. There's a much narrower dimension here than the round can was, and this made it possible to do the MPC 500 mic preamp card, my first mic preamp card design. And a point I started to make earlier before we got started, there were a lot of people that bought this mic preamp card who did not own MCI 500C series consoles, JH500 consoles. Instead, they put them in their own boxes and built their own power supplies. So this is sort of an early form of outboard mic preamps. So that was just interesting to see that thing going on there. It just never entered my mind that people would use this as their own outboard sort of preamp. So thanks to the sort of almost square, it's a little bit not quite square, it's a rectangular. If you look at the end of it, it's slightly whatever. That made this possible. It then made my next mic preamp card, the MPC 600, possible. The input transformer hangs off of this end here. I'm out of input transformers right now, so and there's a whole long story behind that. But this transformer would be hanging off in space, like somewhere right about here with a crazy bracket, because that's the only place it would fit on the JH600 channel strips. They're 2-foot long channel strips. And then along came the MPC 3000 mic preamp card. You can see where the transformer would go if I had them. But at any rate, that's for the Sony MXP 3000 consoles. But they're all very much the same circuit, minor variations here and there. But it's that same, originally JE-16A. The square can version became the B, so JE-16-B. And the only difference is the shape of the shield can. The transformer inside is the same. So whatever, I got started first knowing Deane Jensen and learning about his transformers. And again, I used the JE115KE on that huge console project. And just to show something to you, this is the main input module. I don't know if it'll focus or be whatever. This is the main module for those two consoles that I designed and built for DB Sound in Chicago. The transformer goes somewhere in here. It's missing on this card for some reason. I don't remember why. But, and I don't know if you can see this or not, but I want to point something out here. Don't know if it's in focus or not. But right here, here's a row of white push buttons, and then there's some black buttons. If you look to one side of the button, again, I don't know if it's in focus or not, you can see the labeling of the function of that button. To the other side of the button, there's an LED poking through the front panel. When I designed this console, I was absolutely insistent that every push button should have an LED so that you would know from 50 feet away which buttons were on and which buttons were off. So that design carried all the way through it. And just because this is in pieces here, it's not cooperating. You might be able to see that the LEDs are just tacked on to the edge of the circuit board there. So that was my way of doing it. So that was my first attempt, my first iteration, whatever, of properly illuminating push buttons, etc. And of course, from that came, I think I have a meter card here. This is one of the meter cards for my M1s, M2s, Jensen Twin Servos. So you can see a whole lot of circuitry going on there. Again, I don't know if it's in focus or not, but when you look at the front, there's a push button right here, and it's not lighting up because it's not plugged in. But when I designed my M1, this is my first rack mount preamp, and I was determined to combine all three functions into one here. So you have the push button itself, you have the markings right on the button, and then behind the button, you might be able to make out a green LED right above my finger there. And that sends light through this, basically a light pipe that the button provides. So that was one of my main goals with my design for the M1 was to do exactly that. So that was an interesting experiment, and we sandblast the front end of this to give it a sort of diffusing effect. So things that you do along the way, design goals that I have along the way. So I don't know, where did we start here? Am I off track here, or?
No, not yet. I just wanted to say that I love the push buttons on the preamp. For some reason, when I was growing up, I just loved to push buttons. And sometimes I would wander into the neighborhood and ring other people's doorbells just to see how they felt. But the cool thing about the buttons is, first of all, you get a choice of VU or peak in the meter. And these are the first meters that I used, other than the mechanical ones, that I actually thought were useful, because you did have those two choices. The other thing that I still think is really amazing is that all the other push buttons on the preamp are lit lightly until you push them in, and then they're bright when you push them in.
Right.
So you can see what it is with the light behind it, and then the light is bright if you actually insert it into the circuit. So I thought this was really clever design.
I appreciate that. That was exactly what I was going for. And it reminds me of, I'll avoid politics and religion here, but I will mention in my now former church, we overhauled the sound system in the sanctuary, and there was some ancient mixer in there, and there was another guy who was the technical director of a major venue, and he basically chose the new mixer, which was a Mackie 1604 VLZ Pro or something like that. And it's a decent mixer, gets the job done. But right alongside the fader, there's a series of buttons where you assign where this channel is going to go. There's a main left-right bus button. There's the aux send buttons, so you can choose where you want it going. But there's no lights for those buttons, and those buttons have an unusually short travel to them. So when they're down, they're barely lower than when they're up. And if you look at it sideways, if you put your head down on the console and look across, there is a two-tone knob kind of a thing. It's dark gray below and light gray above, and so if you look sideways, you can kind of tell whether it's up or down. But there were a few occasions when, why isn't channel 1 working? And finally you realize, oh, somebody bumped the assignment button that sends that signal to the main mix bus. So it's exactly that is why I designed. I was just absolutely going to have these buttons here. And again, the module that I just showed you from that console project, that was the best I could do under the circumstances for 1977 with the technology and time that was available. So, but when it came time to design the M1, and I probably started designing it, I don't know, late 1985 into 1986, I was determined to do a number of things, And one of them was these custom push buttons. That I just had to be that. And the metering again was very important to me because and I was doing very little engineering at the time, but it just seems to me whatever you're doing, when you approach a project, you have, I just sort of refer to it as the great unknown out there. What kind of levels am I having here? Is it a ribbon mic with somebody whispering from 20 feet away? Is it a dynamic mic right up against a screaming wall of Marshall guitar amp speakers? Somebody help me. Let me get a handle on this. So the meters on the M1 tell you exactly what's going on just in the snap of a finger. You know just right where you're at. You dial up the gain, you do whatever you need to do to get the appropriate levels. And as Ricardo mentioned, there's the button that's marked VU. When you push it in, you have a slower rise time, so it's not going to show you transients, but it responds very similarly to what an old-fashioned mechanical VU meter would do. So if you like that sort of response, then you push the VU button in, the green LED lights up brightly. If you want a peak responding meter that responds instantly and then has a slower decay time, and I just chose the ballistics on that myself based on what I thought looked good. It doesn't follow anybody's standard but my own, but I thought, all right, that goes up the way it should and it goes down the way it should. Some meters, they just jump around so much it makes you nervous. You want to leave the room. So I just came up with what seemed right to me. And in the meantime, there's a separate red LED beyond the bar graph that's always there acting as a peak LED to let you know when the output level reaches plus 22 dBm or plus 22 dBu, which is almost 4 dB before the M1 or M2 or Jensen Twin Servo 990 microamp, same meter and all of them. That peak light goes off about 4 dB before any of these preamps would begin clipping. So it seemed to me logic here, why don't you tell me a little bit ahead of time? So instead of telling me, hey, you just screwed up, it's distorted, you just clipped your signal. How about letting me know ahead of time? So that was just basic requirements. And
So John, I don't know how many years I had that preamp before I knew about that red LED.
uh-huh.
You could really kick butt on that thing before that LED even came on and not get distortion.
Right.
It was quite a while before I knew that thing was even there.
Yeah, well, then you're working fine. You're doing your job as you're supposed to. But even if it came on, you're still okay, at least as far as the M1 is concerned. Now, I cannot guarantee what the next piece you hear in the signal path can handle.
Right.
And there are always situations where they can handle way less than what the M1 can do. But I just built my stuff. And of course, all of these, the M1, the M2, the Jensen Twin Servo, they operate off of plus and minus 24-volt power supplies, whereas most of the stuff you see, like the lunchbox stuff, the 500 series, those are all running on plus and minus 15 or plus and minus 16 volts. And you can only get as much signal into or out of a preamp as the power supplies will allow. So if you're dealing with plus and minus 24-volt supplies, that's the big time stuff. That's the right way to do it. So yeah, so you're well, again, if the peak light's not going on, then you're fine. But even if it is, you have room to spare.
Mm-hmm.
Of course, back in the analog days, John, people needed to calibrate their tape and everything to the consoles and everything too. So the meters were really important for knowing, 0 dB in this studio is the same as it was over here if people had to adjust and get things calibrated.
Well, there's a detail about the meters, and it's hard to maybe show you here. Let me see my little picture of me. Where are we? Oh, I'm trying to hold this up to my image. Gotta hold it up to the camera, folks. So at the back end here, right above my finger, you might be able to see a little blue thing. That's a jumper, a shorting link, and there's a 4-position jumper there. So you can put that blue thing in any of 4 positions. And I always set it so that it's in the +4 position. If you were to read the labels, there's a 0, a +4, a +8, and then ADJ for adjustable, And the ADJ brings in, there's a 25-turn trim pot somewhere here. Where is it? Right above my finger there, 25-turn trim pot. So you can calibrate the 0 VU operating point of the meter to anything you want over anywhere from -10 to +12. But I always calibrate it so that 0 VU on the meter, that's when the first, here we go, the first 10 LEDs are lit up. Those are yellow, then the last 5 are red, letting you know you're getting into dangerous territory. When you get to the 0 VU point, which is right there, that represents an output level of +4 dBm. And out of all the preamps I've received in for service or for upgrades, whatever, I don't think anybody has ever changed those settings. And it's the same thing with the peak LEDs. I always recalibrate them whenever I'm sending them back out, make sure the meters are right, and nobody ever changes them. So I guess I went to all that trouble of adding those optional features, and just everybody's fine with it, just right the way it is. But that's the way it goes. There's one other, just because useless trivia here. The bar graph driver chips, which are now, I'm using actually a couple of surface mount parts. The through hole parts are no longer available, so I had to convert to surface mount parts, but socketed surface mount parts. This chip drives the first 10 LEDs. This chip drives the second 10 LEDs. For each chip, there's a little jumper that I included. I didn't have to, but these bar graph driver chips can display the LEDs in dot mode, where it's just a single LED that's on at any given time, or bar mode, where you get cumulative LEDs. So anywhere from 1 to 20 LEDs are on. And one of my customers, and only one that I know of so far, he changed it so that the first 10 LEDs are in dot mode, but the last 10, where you're getting into higher levels, that's in bar mode. So that's another feature I probably could have just left out. But what does it cost? You know, a jumper and a couple of pins, whatever. Might as well throw it in there and see what happens. But it's just one of those odd things that's a feature that nobody, apparently, essentially nobody has taken advantage of, or may even be aware of. So, but anyway, that's just stuff about the meter. But that was all things that I thought were important. You've got to know, a man's got to know his limitations, and so do women. You know, we all have to know our limitations. So why not have a meter to tell you where you're at, just to help you out? So that was another design goal. It was very important to have that meter, and I think it holds up. If I may pat myself on the back, I think that that design holds up very well 37 years, 38 years later. It tells you exactly what you need to know when you need to know it.
So John, we have a lot of students here, right, at the start of their careers. Can you talk a little bit about what got you started? How you transitioned into doing audio for electronics? Were you a tinkerer as a kid and got into electronics and then just turned it into this field, or how did you get going?
Yeah, I don't know exactly when I became interested in electronics, but I know that maybe when I was a freshman in high school, something like that, I began building kits, mainly Heath kits, and that was a great experience. And that was back when things were all through-hole parts and none of this micro-assembly sort of stuff. But I probably built 15 or 20 kits. I built kits for some friends. So that was an excellent experience. It gave me hands-on experience with nuts and bolts and terminal strips and resistors and capacitors and light bulbs and this and that. And when you're done building it, you ended up saving money and building a remarkably good piece of equipment, whatever it was. So from that, I started experimenting, I guess. I graduated high school in 1965, again, barely, but I did graduate. So I was playing with electronics at that point. I think my dad had bought a giant console stereo, and that kind of caught my interest. So playing around with that. And there was a family tape recorder, a Webcore monaural tape recorder. So that sort of caught my interest there. And just to show you how things go, and this is obviously how we all go through stages like this, I was recording top 40 hits off of the radio with the tape recorder. And I was doing it probably with a Shure microphone, but more like a CB microphone or something. sticking it in front of a speaker. And I don't know when I first discovered the recording output on the back of the Sherwood stereo, or maybe it was my dad's Hallicrafter's shortwave radio. There was a record output somehow. Oh my God, you mean I don't have to use a microphone? So, we all learn one step at a time. So, well, hallelujah, I can just take this direct signal right into the tape machine. No degradation from the speakers, no degradation from the mics. So there was that. And at some point, I think it might have been 1965, my last year in high school, or thereabouts, I bought my first really nice, relatively speaking, tape recorder, which was a 1/4-inch stereo, 7-inch reels, Roberts tape recorder. And at that time, Roberts was the American version of Akai. I didn't know that till many years later, but it was a Japanese-made tape recorder. But it was a 3-motor transport. So there was a supply reel motor, a take-up reel motor, and a capstan motor, unlike the Webcore tape machine, where there's one motor running everything, as clunky as can be. So this is a huge upgrade for me. And I don't know quite the sequence of events, but I decided to convert that from a stereo tape recorder into a quad tape recorder, a 4-channel tape recorder. And I don't have any pictures of it at the moment, but I had to build 4 individual chassis. I built a box for it, transport at the top, and 4 channels underneath it. And trying to think of all the, I know I had a green, yellow, and red LED, not an LED, and incandescent bulbs along one side for record ready and record and whatever. But I had to buy my own not custom heads, but Nordtronics was a tape head manufacturer back then. And they had a wide range of 1/4-inch heads as well as studio heads. So they were a well-known company. So I oh, be quiet.
Yeah, I was just going to ask if you had to swap the tape stack out, the head stack out, because they were probably only stereo to flip the tape over, right, and go both directions.
Yeah, exactly. Although they had an interesting feature where the playback head could be moved slightly down so that you could do a better job of playing back half-track stereo tapes. So instead of being at the 1 and 3 locations, it was halfway between 1 and 2 and halfway between 3 and 4. That's an interesting little detail there. But yeah, I had to build a new head block for it. And there were enough circuits available, application notes and things like that. And I also contacted Crown in Elkhart, Indiana, and I got a full service manual, full documentation for their CX800 machines and their SX800 machines. They were very similar, but the CX was more of a modular thing. There's a mic preamp card, there's a line input card, there's a this card, that card, a bias card, a line output card. On the SX version, they sort of put all of that onto one large circuit board to make it more economical. But they had very good tape recorders in that era. Crown was a well-known tape recorder company. So I was borrowing circuits from them. I think Nordtronics had schematics for bias oscillators, so I used their thing. And I'm designing my earliest circuit boards, and I might have been etching my own boards at that point. So there's just evolution along the way. And the machine actually worked from time to time. It was not anywhere near, when you start recording, there's a click or a pop. So stuff like that wasn't worked out. And you look at the pro machines, the 24-track machines, etc., and there's stuff going on in there that's just all sorts of details. Mine was just kind of rough and tumble. All right, you start recording, and bam, you start recording. There's no ramping in or ramping out. So, but that machine actually worked, and I still have it in parts around here somewhere. So that was something. And again, I did some projects for DB Sound, just smaller projects at times. And little by little, I'm experimenting. I'm designing boards. I'm making my own circuit boards. And it's all good experience. And even back then, we have the internet now and PDFs, and you can just download stuff and read it right away. But back then, I've made the point over the years that whatever topic you're interested in, whatever era it is, there are probably at least 2 magazines that are dedicated to that topic. Well, audio and electronics, there's enough magazines out there. And you look in there, there's advertisements for the semiconductor manufacturers, the IC manufacturers. You call them up, they'll send you data books and their application notes in the data books. So little by little, you learn from that, and you just keep learning, learning, learning. You know, you learn fact number 1, fact number 2. Fact number 1, I don't need a microphone. I can use the line output. Oh, gee. So, you know, we just keep accumulating facts until sooner or later you realize, I think I know a few things here, and maybe I can do this, maybe I can do that. So as I look back at that project that I showed you, that console module, I look back today and I think, how the hell did I do that? That was just, I'm still waiting to experience an episode of delayed console syndrome, whatever, delayed console project, whatever. I just should wake up screaming in the middle of the night because of all the insanity that went on with that project. But we got the boards out, and for Kansas, and then there were many other groups that DB Sound did sound for. Cheap Trick, they might have done REO Speed, but a long list. They were a major sound company, so they got very good use out of those 2 consoles. There was a front of house console which had 32 channels and a 16-channel wing sidecar. And then there was a stage mix board that had 24 channels and 8 buses, so they could do 8 separate mixes. And again, they got a lot of good use out of those. Now, I will make a very important point here. The module that I just held up earlier, the IM200 modules, don't buy any of them on the internet. Don't buy them. Please, do yourself a favor. Don't buy them. The potentiometers in there, this is one of the side stories. When I was given the green light to start the project, I ordered all the pots for the entire project from Bourns, B-O-U-R-N-S. Excellent pot company. A couple of weeks later, the head of the sound crew, John Robson, R-O-B-S-O-N, that's a character. He decided, we can't use Bourns pots, we have to use Allen Bradley pots. So I had to cancel all the orders and then reorder everything. They had form and function interchangeable pots, same size, pinouts, whatever. So you could use either one. The Allen Bradley pots began getting noisy just within a few years. So the pots are really noisy. How many decades later is it now? So almost 50 years later. So, and there are other issues. The switches are probably all dirty and tarnished, etc. So please, don't think you're going to get the M1 sort of sound quality out of that. You're not going to do that. Because back to the transformers again, the input transformer that is supposed to be used for a 990 op amp is, where am I here? The Jensen JT, well, don't have to see it, the Jensen JT-16, because it has the lowest step-up ratio and therefore the widest bandwidth, lowest distortion, etc. of all the Jensen input transformers. The laws of physics tell you this is the best, assuming it's designed properly, this is the best input transformer you can get, simply because it has a 1-to-2 step-up ratio compared to a 1-to-4 or 1-to-5 or 1-to-8 or 1-to-10 ratio, which the other Jensen transformers have, the various other models. Each one of those transformers is as good as it can be for the ratio that it is built as. But if you want the absolute best performance, then you want the lowest ratio. And this low output impedance coming from this transformer is an ideal match to the noise characteristics of the 990 discrete op amp. So there's a perfect match there between the transformer and the 990. And Deane Jensen was very well aware of that. And I think way earlier in the conversation, I veered off on a tangent there, but it was, I finished that console project in 1977, and I think it was in 1978, maybe early 78, when Deane Jensen sent an application note, an engineering paper, it's like a 12-page paper that he had written describing the entire design philosophy of this JE990 discrete operational amplifier. The full schematic was in there, and he went to great detail to explain all the reasonings, the logic, the approaches, and he then announced right in the paper that he was making it public domain. Anybody who wanted to build that circuit was welcome to do so. I think he regretted doing that sometime later on. He realized, oh, maybe I should have kept control of that. But at any rate, I had been playing with making my own sort of well, I can't think of the right word, a hybrid, where you take a monolithic op amp, which is an operational amplifier, but it doesn't have a very high output stage, a high output power stage, and you add a couple of transistors and a bunch of associated parts, so you add a higher power output stage. I had been playing with that, and I had made a number of these sort of hybrid op amps that would fit into the API 2520 op amp format, which is a 1 1/8 inch square module, about 6/10 of an inch high. And so I was able to squeeze a monolithic op amp and a bunch of other parts into about a 1-inch square circuit board. So when Deane sent that engineering paper out for his 990 op amp, I thought, wow, it's a Deane Jensen design. This has got to be just a superb op amp. Let me see if I can squeeze that into the API 2520 format. That would make it very convenient for people to upgrade their API consoles, the summing buses, the output stages. And just as a side note, I remember years later at some point I sold some 990s to a studio that had an API console, and they put my 990s in the main stereo mix bus summing amp locations. And they called me up when they were done to tell me, when we first turned the console back on, we thought it was broken because we didn't hear anything. And they did enough testing to realize that the 990s were that much quieter than the 2520s, that just baseline sort of broadband noise, whatever, was gone. And they thought it just wasn't working at all. But they started putting signal through it. Oh, signal's fine. It's just the noise is gone. So I don't know if the noise was reduced by 6 dB or 7 or 8 dB or whatever, but it was a substantial difference. And I've heard a lot of people say how the clarity of the mix was much better as well with the 990s in there. So I thought, all right, let me see if I can squeeze this 990 into a 2520 package. And I was able to do that. And I remember talking to Deane Jensen. At the time, I was living in Alto Pass, Illinois, population 300. That's at near the southern tip of Illinois. And that's where those two consoles were built, which was insane on top of everything else, this tiny town. But I was talking to Deane Jensen, and I mentioned to him that I had squeezed his 990 circuit into a 2520 format package. And I think that just kind of went right by him the first time I mentioned it. And so a little bit later in the conversation, I brought it up again, and I think he realized, oh, you squeezed my 990 into a 25. So he realized what I had done, which is not all that impossible, but I was the first person to do it. And so that was an interesting relationship between Deane Jensen and myself, because here I was making his 990 in a package that was available for people to use in a variety of situations. So just one more ingredient in my relationship with Deane Jensen, I guess, and my reliance on his expertise and his knowledge. So again, in 1977, I used his JE-11-BM input transformer in that console project. And then 1978, I started making his 990 circuit design, but I do all the packaging and production design of it. And then it was around 1980 when I decided, I was back in Chicago by then, I decided to do my first mic preamp card, the MPC 500, with the JE-16-B transformer and the 990 op amp. And again, that's a clear 990, the way I made them for the first several years. Thought I'd show off a little, And it was an odd situation where everybody knew what the circuitry was because Deane Jensen had published it. So there's a lot of potted modules where people pot stuff, to hide what the circuit is. They don't want people to know either how good it is or how bad it is, but it becomes a secret. I had nothing to hide and plenty to show off, I thought, to have this done in a clear package so you can see every detail of the packaging for it. So that was 1981, and then again 1985 or so. I don't remember the date. I did my MPC 600 card, then the MPC 3000, and then finally, late 86, maybe sometime 87, came the M1, my first rack-mountable preamp. So I'll pause there because again, I tend to ramble and go in many directions. So rein me back in if you need to. Point me in a direction. I'll be happy to talk on any.
Okay, well, I wanted to mention one thing, John, and I noticed early on that I could go online and actually see a schematic of your preamp. And I don't know of another high-end or low-end company that actually publishes the schematic of your preamp. Not only that, you'll say, okay, here's all the parts, you can have them. Go ahead and build your own preamp. But when I opened up your preamp to look at it, well, I mean, just looking at the inside is a work of art. So I wasn't about to start building my own preamp after looking at this one. But why did you publish all of your schematics?
You know, I don't know. Maybe that wasn't such a good idea. But on the other hand, I think my equipment was always very reasonably priced. And there's so many details of the design that I think probably 99 times out of 100, if anybody was even remotely thinking of building their own, at some point they decided, to hell with it. I'm just going to buy one of John Hardy's mic preamps. It's a done deal. Everything's worked out. There's so many aspects of it that you have to design. I designed a custom aluminum extrusion for the frame of the M1 because it solved a number of assembly problems by doing it that way. It provided structure, on and on. There was and you know, with handling different types of equipment, I remember a Crown power amp that I looked at years earlier before I designed the M1. And they had aluminum extrusion for the front panel, but the rack mount ears attached to the main structural front panel. And with extrusions, you can design it so that there's almost a hole there that goes all the way through the extrusion so that you can tap a screw into those holes from each end. So the rack mount ears were screwed to the ends, be in the window here, screwed to the ends of the main panel. But it was kind of a one-way deal where you're turning the screw into, here we are, you're turning the screw into the panel and it's cutting its own threads. Well, what if you have to take that screw out for some reason? And I did for something. And you got to be very careful the next time you put that screw in to make sure you get it lined up properly so that you don't strip all the aluminum out of the hole there. And if you look at your M1, you'll realize that the top panels and bottom panels, when you screw them in place, they are screwed into stainless steel threaded inserts so that you can take the covers off, put them back on until the cows come home, and the threads will always be there. I wanted stuff, these are little details, but they just, I don't ever want to have to worry about stripping threads anywhere. So that's another thing. All right, things I want to accomplish here. There's this, there's that. There's the meter details I've talked about. But again, from a packaging standpoint, I had to have an extrusion for the front panel, for example, so that right below the top, there's a flange sticking out, and right above the bottom edge, there's a flange. So those flanges are where the top and bottom covers attach to. And if there weren't those flanges there, I wouldn't have been able to fit the meters in where the meters fit. There's just all these details that rely on this custom aluminum extrusion. So that was another thing that had to be done. And then there's the knob.
Yes, that's in your literature, and it's absolutely true. The knobs are fantastic.
I dedicated, pardon me, 2 or 3 paragraphs in my M1 data package to the knob. Now, you'll probably never be able to catch all the details here. It'll probably never focus right. I can't see. But you see a
If anyone wants to try it, come on up and try it. It's right here.
Yeah, there you go. there's a pointer on the top of the knob, which is a laser cut piece of ceramic material held in place with advanced adhesives. And that pointer, you might be able to see it here, sticks out just a little bit, 25 thousandths of an inch beyond the body of the knob, so that if you're looking somewhere else and you've got your fingers on the knob, you know exactly where that knob is pointing because your finger is resting on that little protrusion. But it's not enough to get in the way. If you need to spin right past it, you spin right past it. So I had very clear ideas on what the knob had to be like. And it also had to have a non-reflective finish, so you don't get glare off of the top surface. As I say in my data package, there are a lot of knobs that have sort of a spun decorative treatment to the top surface, and with lights shining on it, you see rings of light or just flares of light coming off of it, and you don't know which one's the pointer and which one's the reflection from the light. This is important stuff. It's like flying an airplane. You need to have stuff that tells you exactly what's going on with the least amount of fuss. And then there's a full sharp diamond knurl. You probably can't see it, but check the one out in the studio there, because you ought to be able to grab it and have excellent traction so your fingers don't slip off of the knob by accident. I'm just trying to think of what's best for everybody involved. And I've seen knob catalogs. I've got dozens of knob catalogs, and I decided nobody makes the knobs the way knobs should be made. So here I am rambling on, ranting about knobs because it's important. Whether you're in the studio or in a high-tech aircraft, if you look at, I've watched a lot of air disaster programs and stuff like that, and you see cockpits, and you see the designs of the knobs, and they are very ergonomically conceived knobs so that they have different shapes to them. There's all these different features because they know that when you're piloting an airplane, everything has to be exactly right, and you don't want to have any confusion at all. Now there's always problems, and well, we learned from that crash that if we move this knob over here, we'd be a lot better off, or whatever. There's always issues that they deal with, always something to learn. But I gave it my best effort at any rate. And I will mention, here's one little side note, you will note that the pointer only goes down about halfway along the height of the knob. And I did that in 1986, 1987, whenever I designed it, thinking that at some point I might have a product where you've got concentric knobs, where there's a larger knob below it and then this smaller diameter knob above it. So I wanted to make sure that the pointer ended partway down so that when you wrap your finger around to grab the knob below it, you wouldn't be accidentally grabbing the pointer of the knob above it, if you follow my logic there. I've never done a concentric knob since then, or ever. So actually, I have a prototype I made long ago that had concentric knobs. But I will probably, the next time I order knobs, I will redesign this knob so that this pointer will go full length from top to bottom. Because that will actually help a little bit, because the pointer will go down all the way almost to the front panel. So if you're trying to line the pointer up with numbers around the knob, you'll have a closer reference point. So whatever, but again, those are just things like that I'm always trying to figure out better ways of doing it. And what's the best way to do this? I'm not limited by anybody else's requirements. I don't have an accountant hanging over me or some idiot president or something. It's just I can do whatever I damn well please here, and so I just design it the way I think it needs to be designed. And here I am 37 years later selling the M1 mic preamp, and any changes have been very minor and slight changes in component values that have really nothing to do with the final performance, moving parts around on the circuit boards. And I think for the mic preamp cards, I'm on version N or something like that, A through N. And the meter card that I'm holding up here is version L, but I think another version or two beyond that, because if nothing else, I had to change from an 18-pin dip package here to this 20-pin SSOP surface mount package because you couldn't get the 18-pin through-hole package anymore. Oh, whatever. You move the furniture around a little bit, you know, parts come in different shapes and sizes, so you have to compensate. Whatever.
So,
Hey,
John,
John.
I just want to point out a few other little details of your preamp that I didn't really realize until I've been using it for a while. One is that each channel in the back has a ground lift switch,
Yes,
not for the whole thing, but for each channel individually, just in case you should ever need it.
right.
And also, it works on any voltage that is in the world. So it's not just for a USA voltage. Am I right about that?
Well, two versions. Up until about 5 years ago, the power supply was built with a large and heavy round toroidal power transformer. And that transformer had 4 primary windings on it. It's a fairly complicated transformer. There were 2 100-volt windings and 2 20-volt windings. And then there was a 6-position voltage selector switch made by Schurter, I think. And you had 6 choices. You could set it for 100 volts, 120, 140. I think there's a mountaintop in Peru where they have 140 volts or something. And 200, 220, and 240. Now, a lot of companies they have a transformer with 2 primaries, a couple of 110-volt primaries. So you either set it for 110 or 220. But I wanted to go full tilt and be able to do finer adjustments. So in Europe, is it 220 or is it 230 or is it 240? And there's plenty of voltage reserve so that if you have a brownout sort of situation, there's still enough excess voltage coming out of the power transformer that things are still going to work the way they're supposed to work. So I had that situation from 1987 until 2019 or so. And that 6-position voltage selector switch was getting harder and harder to find, and the prices were skyrocketing. And I finally decided to change to a totally different approach. And I just happen to have a power supply card here. And this is not fully assembled, but instead of a round toroidal power transformer in here, there's a series of switch mode modules, which each individual module will take anywhere from 85 volts AC to 265 volts AC or 305 volts AC, and convert that to whatever DC voltages you need, though I go one step further than that. For example, down in these 4 modules here ultimately create plus and minus 30 volts DC, but then there are places for 4 voltage regulators. Kind of hard to point them out, but there's a regulator here, a regulator there, whatever. There's voltage regulators that take the plus and minus 30 volts, and there's with additional filtering between these switch mode modules and those regulators, there's additional filtering to get rid of high frequency noise, and then regulates them down to plus or minus 24 volts for the sake of the 990 op amps, etc. So switch mode supplies are sort of notorious for being noisy because you're converting energy at probably 100 kilohertz, 132 kilohertz, something like that. There's tiny transformers inside them because you're recreating AC at 130 kilohertz or whatever it is. So there's a lot of hash that can result from that. I do some filtering in between those modules and the final linear regulators, but then the linear regulators, of course, do their job to get to the final DC voltages. So this power supply design automatically adjusts to any AC voltage, again, from 85 volts AC up to 265 or 300, whatever. On the old design, you had to open up the preamp, and there was this big black round switch, and you take a quarter or a giant screwdriver and clunk it through the 6 different positions. And every now and then, somebody goes from a 120 volt situation, they go to Europe where there's 240, and they forget to change it, so they, whoops, Fortunately, nothing real serious has happened, but a fuse blows in a hurry, and the transformer does a lot of buzzing before the fuse blows. But, so that's I'm trying to make things better and cheaper, faster, better, whatever you want to say. But again, this design is makes the supply is the overall preamp is 2 pounds lighter because you get rid of the heavy toroidal transformer. I've also replaced what is normally a couple of copper heat sinks for 2 regulators here and 2 regulators up there. I've replaced them with aluminum because there's much less heat being generated. So it's silly to use copper for the heat sinks when there's just not that much heat that needs to be moved to the front panel or the rear panel. So I just keep updating the design, but leaving the fundamentals alone. So, which is something I'll mention this, we can jump in or out at any point. But I'm behind in production here because I am now building my own output transformer, the model 11C. I don't know if you can see that well enough. This is basically a duplicate of the Jensen JT-11-BM. So I fully studied it and I decided to make my own. And I have the same situation coming up with the input transformers. There's a a statement that I send out to a bunch of people here. Let me just find it because I have it handy. I'll just read this to you so I can send this to anybody if you want it. But I explain to people when it comes up in an email or something, I explain how I'm in the process of designing my own input and output transformers to replace the Jensen transformers that I've been using since day one. Here is an announcement that appeared on gearspace.com a few months ago. Well, that was more than a few months ago. But anyway, it says, I am pleased to announce that the John Hardy Company is now manufacturing the Model 16C light input transformer and 11C line output transformer. These transformers are now being used in the M1, M2, and Jensen Twin Servo 990 mic preamps of the John Hardy Company. The 16C and 11C replace the Jensen JT-16-B and JT-11-BM transformers respectively. The 16C and 11C are built to the exact specifications of the Jensen models. And then I go on to explain why. The John Hardy Company experienced long delivery delays from Jensen transformers that started in June of 2012 and lasted for a year. There were more delays in 2018, 2020, and beyond. The ownership of Jensen Transformers Incorporated has changed hands twice since 2014. In late 2023, they moved their entire operation from Chatsworth, California to Vancouver, British Columbia. It was time to make my own transformers right here at the John Hardy Company to eliminate costly delays and to guarantee the highest quality. So that's the basic description of what's going on there. So the 11C is a very straightforward transformer. It is I'll get into a little bit here. It's a bifilar wound transformer, which simply means there are 2 windings, a primary and a secondary, bi meaning 2, filar meaning, I'm sure, filament, so 2 filaments. The 2 wires are wound literally side by side as they go, as the winding machine moves the wires back and forth across the bobbin. And so you're literally winding the exact same number of turns, because you can't escape it, you're winding them at the same time. So you wind the proper number of layers, the proper number of turns, and if you do it with careful control of the tension on the wires, it takes very careful control of the tension with tension controllers. If you do everything right and you're doing it the way Jensen does it with the same 80% nickel laminations, the same bobbin size, etc., if you do everything right, you get the same performance. So this is pretty straightforward. This is in production. I just went through my first couple of spools of wire. I need to order more wire, but that's that one. The output transformers are, the input transformer is way more complicated. I'll get into it a little bit. There are, of course, there's ultimately a primary winding and a secondary winding, but it consists of 3 primary windings and 2 secondary windings that are interleaved. I'm not looking at my hands, I'm looking somewhere else. All right, look at my hands here. So you wind a primary, then a secondary, then a primary, then a secondary, and then a primary. So you have 5 different windings. There are specialized winding techniques used on some of the windings. There is a copper foil shield in between windings to eliminate electrostatic interference. There are lots of other details. I won't go into the details because there are certain things that I'm doing that will leave the fundamental design alone because I respect Deane Jensen's genius to designing transformers. But there are aspects of the manufacturing of the transformers, the methods used to manufacture them, and in some cases the materials used, where I have found ways that I can neaten things up a little bit. So just as one example, here's, just to make a point here, and it probably won't be in focus, but here is the bobbin from a Jensen output transformer. And here's the bobbin that I'm using, which is the same bobbin. So just to give you the idea that obviously I'm starting the same. On the input transformer, and again, with the output transformers, you just got 2 wires. You got 2 wires at the beginning, you've got 2 wires at the end. Fairly straightforward. With the input transformers, you have 5 windings. That's 10 ends of wire, 5 beginnings, 5 endings. Each one of the 4 copper foil shields has a piece of wire soldered across the middle of it, and that piece of wire goes up along the inside wall of the bobbin to get to the outside world. So for every one of these windings, when you start a winding, I'm using the larger bobbin just to make the point, you have to get that wire to go down to the bottom, the floor of the bobbin, tape that wire in place, then wind the winding, and then when you're done, the other end has to come up along the inside wall of the bobbin. So you've got 10 wires either going down into the winding area or coming out of the winding area, and you've got the 4 termination wires coming from the copper foil shields, and there's pieces of tape holding all of that in place. And I just came up to the logical conclusion that the winding area should be a sacred area for winding. It shouldn't be where you route wires into and out of the winding area. I said to Ricardo the other day, imagine, this is not a good analogy, but imagine you design a beautiful living room, a custom home, and you have the greatest plasterers from around the world come in and plaster your walls, beautifully plastered walls. And then in comes the electrician who runs conduit all over the walls to get electrical power to and from the outlets and wall switches and whatever. No, you ruined the plaster walls. What are you doing? Get out of here. So I just decided, rather than route the wires down the walls or up the walls, I'm going to just have them come straight through the side wall of the bobbin where they need to be to either start a winding or end a winding or to terminate a shield. So that should make more uniform windings because you don't have a winding that's going along and, oh, it's got a detour around those wires and the tape holding them in place. Just seems to me that that's a common sense thing to do. But they do it that way, I think. I'm not there, so I can't say. But they do it that way at Jensen because that's the way it was done in the early days when the transformers were made by Reichenbach Engineering. And Reichenbach did it because it's a good, solid way of doing it. But that was before Deane Jensen came along with superior designs. And even at that, there was, I can tell somewhat of a story here. Deane started making his transformers in the early 70s. By the mid-80s or so, I remember Deane telling me one day that he was increasingly dissatisfied with the consistency and the quality of the windings that he was getting from Reichenbach Engineering. So he began looking for another company to do the winding. Because at Reichenbach, they were using old-fashioned mechanical winding machines. If you wanted to have more turns per inch or fewer turns per inch, you would change a gear set inside the winding machine, or you would lengthen an arm that goes back and forth. There's just all these mechanical things, totally mechanical. The new winding company had computer controlled and programmable Swiss winding equipment, CNC equipment, basically, where you program it to move the traverse arm back and forth across the bobbin at a precise rate and down to the 1/10 of a thousandth of an inch or better. And if you want 288 turns, you get 288 turns. You don't have somebody watching a turns counter. Oh, it went past 288. Well, whatever, 299 turns, close enough. It's just whatever. So there was this evolution at Jensen. So just one note about that. The earlier models of Jensen transformers, I think they all started with JE as the prefix. But when they moved the winding of the coils to this better company, Jackson Engineering actually, they changed the numbers to JT. So there was an evolutionary change going on there, but an important one because the transformers became much more consistent at that point. And one last story about that. Before the change was made from the JE to the JT numbers, I would order maybe 50 pieces of the input transformer, and each one had an ID number on it, and there was a page of listings that had the ID numbers broken down into maybe 4 or 5 different groups, and there's a termination network that you have to connect across the secondary winding of the transformer to properly terminate it, to fine-tune the performance of the transformer. And that consists of a resistor, typically a 6.19K resistor, and then there's a resistor and a capacitor in series with each other. And the way the transformers were before they became the JT numbers and wound much more precisely, those RC values, the resistor and capacitor in series, there might be 4 or 5 different groupings where you had to make sure that this batch of transformers got this set of values, this other batch of transformers got the other set of values, etc. But Deane Jensen realized that there's got to be a better way to do this. And so eventually those transformers were wound at the new company, and those values shifted a little bit, but they were rock solid, always the same. I never have to worry anymore about getting the right one on the right card because they're all the same. So consistency of winding, and that's done by better winding equipment to begin with, where you tell it exactly how many turns and you get precisely that number of turns. You set the tension for exactly what you want, and that's exactly what you get. So, all right, that's the end of that story. So, next.
John, we're well out of time now. So is there anyone else who has any questions at all?
How do you, were there any unexpected failures when people came back to you to repair preamps? Was there anything you didn't expect to break that came back?
Nothing that I can think of offhand. I know in the early days of the 990, 1981, there were hundreds of 990s that were being used by Sony in their PCM 1610 A to D converters. And I had a rash of failures with those 990s because, and this is an important detail, when you pot an electronic circuit in epoxy, you have to be very careful to match the coefficient of thermal expansion, CTE. How fast does the epoxy expand and contract as it gets hot and then cools down compared to the components themselves? And there are a lot of epoxies out there that expand at a much higher rate than the parts do. So as something heats up, if the epoxy is expanding faster than the parts, in my case, it was pulling diodes apart. So they became open circuit. And depending on which of the 11 diodes in the 990 went bad, it would either fail catastrophically, or it might even be a diode where it's not even really in the circuit unless there's some unusual situation. So I remedied that problem by doing 2 things. I changed diode suppliers in case that was a diode problem. I went from Fairchild diodes to ROHM, or ROHM, R-O-H-M diodes. and I changed the curing schedule for the epoxy. Rather than curing things for 8 hours at 100 degrees centigrade, I cured them for 12 hours at 90 degrees centigrade, thinking I'd be building up less stress. And the problem essentially went away. There's still occasional failures. It is a discrete op-amp circuit dealing with the wild and crazy outside world of audio. You never know how people are using these things, so there's always that possibility as well. So, but generally things have been very reliable as far as I'm aware of. I don't think there have been any serious issues. And so I hopefully that answers your question.
Yeah, I had a question too. What makes the 990 such a good op amp?
Deane Jensen's design of the 990. And if you read I encourage you to read the 990 data package, which is available on my website. And page 1 explains why I made the decision to change from through-hole assembly to surface mount assembly for all but the 2 power transistors, the output transistors. Those remain through-hole parts. But there's a lot of discussion about why a discrete op-amp can be better than a monolithic op-amp, because when you look at a monolithic op-amp, and certainly they have improved over the years, but a monolithic op-amp, you have to create transistors, resistors, capacitors, diodes, all on the same chip of silicon. And you're never going to get the best of each one of those when you have to sort of compromise in the optimization process, because they're all being created at the same time on the same chip of silicon. With a discrete op-amp, you can get the supermatched pair of transistors, which is now the SSM2212, and those will be the best matched pair of transistors you can get because they're fully optimized to be matched pair of transistors. So they don't worry about resistors or capacitors or diodes. They're building a sole purpose device there. But same thing with resistors. If you buy surface mount resistors, one of the improvements I made was to go from resistors that generally have a 1% tolerance accuracy factor to most of the resistors are now accurate to within 0.1% of accuracy, because in the world of surface mount parts, there's so much engineering going into them, and it's so competitive that they just keep improving and improving and improving them. So I was able to improve the tolerances, tighten up the tolerances. Totally unnecessary, all things considered, but hey, I've come this far. I'm going to spend a few more cents per resistor and go from 1% to 0.1%. And it's the same thing with the capacitors that are in there. You can get higher or tighter tolerance parts, etc. And again, with surface mount, almost everything is two-dimensional. Instead of, you probably can't see it on this, well, yeah, you probably get an idea. Here, all these parts on the 990 are standing vertically on the circuit board. That's what you have to do because there's no horizontal room for them. So to do it, back in 1979, 78, whatever, that's the way you have to do it with through-hole parts. So, but with the surface mount parts, everything can be lying down flat on the circuit board, and that eliminates or greatly reduces any sort of inductance that might be there. Just, I forget the proper term for that, but if you have a resistor that goes up and then loops back down, you've also created a small inductor there. So if you can just lay the whole thing down flat, then you've reduced the inductance by 90%, something like that. So surface mount, if you can do it, is a really good way to do it. There are people that will argue all day long about quality of these parts versus those parts, through-hole versus surface mount. But in my mind, surface mount technology they just keep pushing the technology and getting better and better parts, tighter tolerance, lower drift parts, etc. So that's my view on things. Not sure if I answered your question or not.
That makes sense. That's actually like more informative, I think, than what I was asking.
Okay. Well, that's good.
Are there any other questions? Yeah?
What's your favorite mic on your preamp?
I have no favorite mic. That's up to you folks. But I'm trying to think of a saying. I used to, used to, oh yeah, a number of quotes that I have, and one of them is rediscover your microphones. And I've had people tell me that they, stories from long ago. And gee, before I got your preamp, I thought that this mic and that mic just wasn't very good. But when I got your microphone, I realized it wasn't their fault. It was the fault of the mic preamp. So there's just even, of course, I bow down to the Shure SM57 or 58. Yeah, what a story, you know. And I haven't shopped for one for a long, long time, but they used to always be available for under $100. I don't know if they still
They're
are.
still
They're
100
still
bucks.
under
They still
100.
are.
They're still about there.
Yeah. So
So Andy, years ago I asked John Hardy the same question, and I said, "What mic sounds good with your preamp?" And he said, "Every mic will sound better with my preamp."
Good answer.
yeah,
Hey, John,
that's,
I read that you were a musician. Is that accurate?
yes, I I
Did
made
you?
sure to note that because I realized I'm in Wikipedia twice for useless things, but there were two Chicago-based bands that were around in the mid to late 60s into the 70s. One was a group called the Shadows of Night, KN.
Gloria.
Exactly. Jim,
Gloria.
yeah, Jim Sands.
I used to play that song.
Everybody played that song. If you were
Yeah,
around then,
it's
you
only three
played that
chords.
song.
I think there's only three chords.
So, pardon me. In my travels, I've been in a lot of bands, all things considered. And there's a particular drummer where we realized we had been in like 7 bands together over the years. It was nuts. We always had a good time. But at some point, um, in the late summer of 1970, the group The Mauds, Mauds, they had a few songs that charted. By that I mean it got below 100 on the Billboard charts, and then the Chicago chart it got up to I don't know. So they were a somewhat popular group and a group of some note. And somebody made a Wikipedia page for them, and I was a member of the Mods for several months until one of the crazy guys in the band at that time. The band had broken up, and then there was a talk of a record deal. So Jimmy Rogers, the founder of that group, put together a new group of musicians, some from the old band, some from the new. So one of the guys, after we'd been playing for several months, one of the guys said, "Oh, we have to change the name of the band. Oh, we're not the Mods." That is kind of a weird name. So we changed the name of the group to Flash, which then actually there was a European group I think named Flash, but whatever. So I'm in Wikipedia because someone put a Wikipedia page up for the Mods, and then at some point somebody put a Wikipedia. So the Mods at some point they broke up. The first time they broke up in May of 1971. So I got a call from this drummer that I'd been in a bunch of bands with, and he was playing drums with the Shadows. He said, "Hey, you want to join the Shadows?" So I played with the Shadows for 3 or 4 months until the Mods, although Flash at that point, got back together again. So I'm in the list of musicians for the Shadows of Night and for the Mods for whatever. That won't buy me much of anything, but I'm in Wikipedia twice for whatever that's worth.
He is, I've checked.
So had a lot of fun, played a lot of great music, and
Congratulations on all your great inventions.
Are there any other
Great.
questions?
well, thank you, and thank everybody for using my stuff. Again, where would I be without the customers? But again, when I first started making the M1, I just crossed my fingers and hoped people would like it. And didn't take long to realize people loved it. And I began to realize, holy cow, there must be a pretty good preamp here. So, but again, you look at all the ingredients and everything is the best it can be. It's the world's best input transformer, a superb discrete op amp, world's best output transformer, no capacitors in the coupling path, the signal path. So it is what it should be, assuming you do it right. Now, even then, I think I said earlier that you can probably give the same schematic to 10 guys, and it may not sound the same because of grounding issues. Grounding is such an important part of the design, and I'm just looking to see. No, I can't show you. I don't have a board handy. But on all of my designs, if you can get the right view of it, the ground pin of the 990 is what I have defined as the 0 reference point. And if you study it, if you look at the circuit board, you'll see there are lots of things that need to be grounded, and they all have their own private path back to that 0 point, so that there cannot be any interaction between them, because they all have their own unique path back to ground zero, whatever you want to call it. And there were lessons I learned along the way where I realized if you don't do that, there's interaction and things just don't behave right. So it's more important in audio maybe than anything else. So there's that factor as well.
Okay, one quick announcement, and then this is our last seminar of the school year. And I want to thank you, John, for being here with us. And if anyone is in the Chicago area and wants to go and create a summer job for yourself, go to John Hardy's basement and get some of those repairs done.
Yeah, I'm so backed up in repairs here, it's insane. I'm embarrassed by how many repairs I have, just things that have accumulated over the years. Back when the COVID lockdown happened, I've said this to Ricardo, I had a young woman working for me, and I had a few repairs come in. I set them aside for her because she was maniacally meticulous with everything she did. Well, she decided to quit and move to Hawaii, and that's a whole other crazy story. And then I just never quite recovered since then. So I've got a ton of repairs, and then I'm in the middle of trying to design some transformers here, you know, and production going on that. So that's not the easiest thing to do. But I'm getting there, and I know that the input transformers will be done soon. I'll have them done, and they will be every bit as good as, and maybe even a little better than the Jensen ones, as I've described. But anybody's always welcome here, and always call ahead, you know, make sure you, and I haven't answered my phone in a long time either, so email me. If you're ever in the area and you want to stop by, you're always welcome to do so. And there's always ice cold Cokes in the refrigerator in 8-ounce glass bottles. That's the drink of the house. Plus, I got a wide assortment of other stuff too. Nothing alcoholic, but at any rate.
Okay, well, if there's anything you can farm out to the 8th students here at Carnegie Mellon, see, they're ready to go already.
Well, you never know. I'll give it some thought, but
Okay.
I've got to do my own programming here on the machine. It's not that hard. I just seem to never quite get to it. But anyway.
Okay, and there's also some genius computer science folks here as well. Okay, anyway, John, thank you so much for being here, and I hope to talk to you soon again.
All right, well, thank you for having me. I appreciate it. Thank you.
Thanks, John. This is great.
Thank you, John. Yeah, thank you.
Bye-bye.